Okay, so firstly, thank you for having me here for this conference, this presentation. I'm probably going to continue along a relatively similar theme to Bill's presentation there. And what I'm actually going to try and go through here is, firstly, why we believe as Trimble that it's important for us to start taking information from the models, from the constructible model and so on, and bringing that into the FM world and helping to manage not just the ongoing maintenance, but also the life cycle planning of that. My experience historically has actually been with our asset management system, the EAM, or Enterprise Asset Management System, sometimes referred to as Atrium. And we've been offering that solution out to the market for around about the last 20-some years, 23, 24 years now. It's obviously evolved with technology over time, and originally was a DOS-based blue screen system way before I worked with it, but now it's obviously a web application and so on. What Trimble have is a lot of experience within the sort of design, operation, and life cycle of buildings. And what we're able to bring with this application is sort of looking at the operational life cycle. So, as was mentioned in the sort of introduction there, Trimble undertook an acquisition of Gary Technologies a little while back, and that allowed us to start to integrate our asset management system in with what is now called Trimble Connect, but used to be called G-Team. I don't know if anyone's familiar with that at this point. But what I wanted to take you through is sort of why we've gone down the route of bringing that and what, into the frame, and show you actually how that's worked for us, both in terms of consuming the data and then interacting the model with our ongoing FM and ongoing asset management processes. So Bill in the previous presentation actually talked around, well, what happens if we just introduce the model and we're introducing it for a selection of buildings? We've got to go through a change process for the individuals to actually engage with that model, but we've got a wide variety of buildings that aren't actually in that position yet. And what our sort of argument is we can build in, we can utilize the data that sits within BIM, and we can utilize the visualization that provides, but we need to align that with the existing maintenance and asset management processes that we already have. So that's sort of the sort of overview that I'm going to sort of hopefully go through. Now, I was actually just last week at a conference that was focused on lean and talking around how lean delivers efficiency, increases productivity, reduces waste and cost throughout the design and construction process. And it sort of struck me while I was at the conference that there was an awful lot of focus on this, and real pressure on the design and construction frame to say, let's keep those costs down, let's reduce that waste. And I sort of thought, well, why do people stop talking about that as we start to get to the handover, start to get into the operational life? Now, I don't think it's quite fair to say that people do just stop talking about it. It's just that we don't necessarily continue in the same vein. And I think there's a lot of efficiency that can be gained by utilizing the data and the information that is captured during those processes, and starting to really make the most of that, not just in terms of planning the maintenance and what we need to do for that each year and so on, but also the whole life cycle cost, the full investment that we're going to face for that particular building or asset. And why do we need to do that? And buildings are costly. So around about 80% of the life cycle, the cradle to grave life cycle of a building and an asset will be in the operational life. Around about 20%, therefore, in the design construction phase. So it's actually, you can see there that if we're driving so many savings through lean and so on within the construction end, we can drive a lot more efficiency within the operational life. After all, buildings will be there for an awful long time, certainly decades, maybe hundreds of years, depending on the type of construction. Also, for the organizations who are owning or operating those buildings, it's the second highest cost to that organization, typically after the people and the staff that they employ. And certainly in the UK, we have, with the financial crisis over the previous few years, asset management and building maintenance and so on really took a much more prominent focus for the industry, mainly because they went and laid off everyone they could do at the first hand, and they couldn't get rid of anybody else, so they had to start focusing on where else they could drive the efficiencies. Now, it's a sad truth, but it is the truth. Unfortunately, a lot of people were made redundant, and asset management really sort of took off. It was already there, but it took a lot more prominent focus in the UK particularly, which is where a lot of my experience is. So we really had to start to sort of understand how organizations started to try and really drive those efficiencies, sweat the assets. They didn't want to make major capital investments. They wanted to push those out, continue to do what they were doing. And the only way we can do that is if we understand what we own, where it is, and what investments we can make to improve that. Sort of already mentioned this, but and Bill sort of highlighted it really as well with the map, which I think was quite interesting, looking just across your campuses there, is around about in excess actually of 90% of buildings that are already around today will still be here in 2050. So that's a lot of buildings that we don't have BIM for. That's a lot of constructions that we're already running some sort of platform or some sort of maintenance process on without having to go out and actually model it. And I'm going to try and talk around how we can integrate the new builds, the ones where we do have BIM, with the existing data sets that we're already running, but also give you some options for how we can capture the information and start to consolidate those into everything being run in BIM. And I've got some colleagues in the audience from both Trimble and Building Point, and we have a standout there which we can talk to you about that as well. But really what we're trying to do is sort of understand where we should be investing, what time we should be investing in, and whether that's a sort of minor maintenance, ongoing upkeep, or whether that is major refurbishments. We need to understand the point at which we need to invest, and also weigh up the cost versus the risk of either investing or not investing. And I think that in order to do this, we already know this. I'm probably sort of teaching you to suck eggs a little bit here, but to make these decisions, to drive this forward, you've got to have data. And really, that's what where the interest comes from the asset management point of view in BIM is, it is a very data-rich environment, can be a very data-rich environment, and we need to start making better use of that information as we run into the operational life cycle. And to that end, Trimble as an organization, as I've sort of already mentioned, have had a quite historic or sort of a lengthy focus on managing the design and the build processes. And we're growing into delivering this sort of operational life cycle with a lot of the software systems that we're able to provide. And we have this sort of DBO, design, build, operate strategy that we're focusing on, where right the way from the design, we have applications the likes of SketchUp and so on. And I'm not going to name every application; it'd take me all year. But things where you can actually go through the conceptual design phases, you can capture information for the DTM and so on. So all of that information can be gathered right at the outset. That can be passed on to the build or the construction, where you get into the constructible model, and we've got applications such as Tekla, where you can again start adding additional information into those models. But for a long time, we've sort of the BIM particularly has been used in those phases, and we've got to the operational phase, and that hasn't been handed over. That information, that model, that data hasn't been handed over to the operator of the building. And it does take organizations like Princeton actually going and asking for that information to be handed over so that they can make use of it during the operational life. And I really think that there's sort of a missed opportunity that's been there for a long time, and the industry's wising up to that now, and we're starting to take that forward. So what we're trying to sort of plug in here is that data can be used. It could just be that we're taking Kobe files or any other sort of output from it, but we also want to make use of that visualization capability here as we move into the operational life cycle of the buildings and the assets. And why is it that we want to make such a use of that information? And again, it was highlighted earlier that it may be that there's some slightly additional cost to capture all of that information during the construction phase. But if you don't do that, then you get into the operational phase. You have a building you don't know enough information about. That leads you to potential problems downstream with the maintenance programs. And you might have to go out and either resurvey through CAD or use some GIS information, or actually walk around with tablet devices undertaking condition and defect surveys, or even just a full asset capture exercise. And the estimates that I've looked at sort of come to the conclusion that if you don't take that information on straight off the back of construction, the cost of gathering that information can be about 8 times higher than. So yeah, there might be a slight increased cost to engage with the construction teams and so on to provide you with that information straight off the bat, but it certainly has a much sort of lower cost long term over the full life cycle cost, because Then we can understand what our reactive and planned maintenance programs are, how we should be implementing them, what regimes we should put in place. We can even then allow contractors more accurate access. We can say, this is the work that we're going to actually have to do. You know, we're going to service boilers, and this is how many we've got. These are the types they are. These are where they are. All of those deliver ongoing savings and so on. So I do think there's a missed opportunity in terms of handing that information over. And you're all well aware of the types of data that you can then go and capture within a model. And the information can be sort of fairly low level, like the width, height, depth, and so on, and we can consume that information. But we want to know information about the supply date, the cost of supply, the ongoing O&M information. If we can start to consume all of that into an existing asset management database, then we can really start to deliver those efficiencies there. So what I thought I'd do is, just before, I'm actually going to dive in and show you a couple of videos of some of the integration pieces that we've got. But this is actually a life cycle that that was presented to me by one of the organisations that I work with, which is the Environment Agency. So UK-based, they manage all the flood risk assets across the UK. So that can range from pumping stations to some of you may have heard of the Thames Barrier, quite a complex piece of kit that will stop London flooding every day. And it's not just a piece of kit, it's more than that, but you know what I mean. But also, embankments. They track actually all the rivers in the UK for dredging to prevent flooding, to try and protect many people's homes, including my own, from flooding. So one of the first things that they sort of came to us and said is, this is what we want to do. This is what we need to do on a day-to-day. You're all probably aware of this, so I'll fly around it. But they need to know what assets they're responsible for, where they are, what sort of condition they're in, how they perform, what assets they actually need. So they start to make some decisions around, do we need to keep hold of this? Could we actually dispose of it? Do we need more? Should we be building another seawall or something like that? And then they need to understand what the investments are, what they can afford to do, and then who's going to actually do that. And all of this they wanted to make into a very, very sort of smooth, easy to run process. So you've got the central management team who are building up the various investment plans, and then you've got the engineers going out on site, and they've got about 1,400 internal engineers. They need to get out on site, so they need to have access to that on a mobile device. We want to be completely electronic with this information, so removal of paper. They are the Environment Agency after all. They're not too keen on printing things. So they want to get out there, receive the information, receive as much of the visuals as they can out on the site. Now, if we can make available the asset details, the maintenance history, the condition grade, the O&M manuals, everything like that, that's great. What we're also making available is the map to some of those, often quite difficult to find assets. And then as we get into some of the more complex assets, providing the BIM data out to them and providing the visuals for that and allowing them to, in exactly the same way as we were seeing before with the various eyes, to go through and turn on and off the items that are of interest to them for that job, is a hugely powerful thing for those individuals to have access to across the whole of England as they're trying to stop the place from flooding. So to support the accessibility of all that information, Trimble have an application called Trimble Connect. Now, Connect is basically a collaboration environment designed to increase the accessibility to BIM data to people throughout that DBO lifecycle. So you can see a variety of tools that Trimble have here, but it doesn't just plug into Trimble applications. It's just that's what I have on the slide. So you can see around here all these different applications that are capable of sharing information. So the tool is actually built on APIs and isn't just focused on BIM, but that's what I'm here to talk about today. So I'm going to focus on how we can load information into Trimble Connect, IFC files and so on, and then we can sync that data out into an asset management system to improve the way that we run the maintenance processes, improve the way that we do our investment planning, and make a lot of that information accessible to the guys out on the ground. So I was going to sort of dive in and do a quick demonstration, but the Wi-Fi is a little tricky here, so I've just got some screenshots. But this is the application that was used by or designed and developed by Gary Technologies. It's now been rebranded to the sort of Trimble Connect. It's all browser-based. All the models are accessible in the cloud. And once you've got access to it, very easy to move around. We've actually got just at the top a number of icons, one of which gives you an exact drop down as you've seen before with the eyes, and you can turn on and off the various items and elements within this. So it just allows me to move around the model. Now I've turned off the roof, and I can see all the information. Could be any of the mechanical, electrical, plumbing information, could be furniture, anything that you want to have loaded into the model. So this is actually my office in Bristol. So you can see I actually sit in the top corner there with the one without a chair. They obviously didn't want me to stay too long, so they keep shipping me off to the other side of the world. But what we can do within this is not just make a visual, but we can come in like we've done here with this green asset. We've sort of highlighted that information. All right, it's a set of stairs, but you get the point. We're then able to pull through not just information that's contained within the model, and show that there's a properties piece. I've actually cut off the screenshot on the right-hand side. We can pull through information not just that's captured in the model, but also that's held and recorded within the asset management system. And that could be information relating to the most recent condition, the most recent maintenance order, any of the information that we're already recording. Now, in order to achieve that sync, just as Bill was talking about, we obviously need to make sure that the asset information is able to sync between the two. We're using the same naming conventions and so on. Now, one of the strengths that we have is within the Atrium application, we classify all of the assets. In order to run an asset management system, it goes without saying that you have to have a pretty strong classification structure. And so what we're able to do is actually export and publish that classification structure so that when organizations are building up these models, we're able to say, you have to classify these types of asset, record them with this type of naming convention and so on, so that when you're loading the model into here, we're able to draw on that information and populate the asset management system without errors. So I mentioned already the Environment Agency. Now they've got some 158,000 flood risk assets that are across England. We have naming conventions to capture not just the assets themselves, but all the various component parts of each of those assets. They're recorded within the Atrium application. They're going through a process. They do about £1 billion worth of capital projects every year, so a lot of new constructions. There's been a UK government mandate for all new construction projects to utilise BIM to its best effect. And so the Environment Agency are now looking at all new projects having a BIM component. Off the back of that, again, they deploy the BIM details into a CDE or into Trimble Connect, and we're able to then draw that information down into the Atrium system on handover from the construction to the operation. There's then information within the system that can auto-generate the ongoing life cycle maintenance plans. So if I use an embankment, they'll say how often it has to be mowed, how often they have to clear the pests and the foliage and so on, things like that. So it's a really powerful tool to be able to consume that information, know the type of asset we're looking at, and automatically generate the maintenance programs off the back of it. And this is the application itself, or the diagram we use to describe the application. So you've got the operational maintenance delivery on the right-hand side and condition survey data collection using this assessment works occupancy area. But then on the blue side, we're also able to utilize that to build up investment plans, understand the current performance of the asset, build up a variety of optional scenarios. You know, what if I did this amount of maintenance? How much is it going to cost me? What performance improvement is that going to return for me? But it's all tied back, and all of the information that we have is linked back to the asset record within the portfolio module. Without that, none of the application will run. You can't do any of the planning. You can't run any of the maintenance. So that's where we see this just absolutely critical that we start to take hold of the information that is already available for the existing asset base, but particularly consuming it for new assets as they come on board. So I'm going to skip through that, and just what I'll actually show you here is a video. So these screens are actually an illustration of how we would show the performance within the system. So we can highlight where we've got major risks across a variety of different indicators. And then when we're doing an investment scenario, we can build that up. The reason I flag that just before I go into this, the video of the solution, is that performance change is a piece of information that we can upload and make visible in the model. So we're able to say, here's how all the assets in this building are performing. Here's what it would be if you made that investment. So this is actually just going to run a video. And what I'm going to do is just take you through a building that we've trialed this on for the Royal Institute of Chartered Surveyors. Is actually a building based in just off of Westminster Square in London, and the Royal Institute of Chartered Surveyors building has actually been there for I'm trying to think now. It's I don't know, a long time, long before BIM existed anyway. But so there wasn't a model of this, a constructible model, as I'm sure you can imagine. So what the RICS actually did was went out and had a point cloud created. They turned the point cloud into a model using the relevant software applications, and then they provided that to us. Now we've got in the application here on the left-hand side a breakdown of the site level into the floors, into the rooms, into all the asset components that are then recorded for that room. And you'll notice in the bottom left, we have a BIM view capability. So I'm looking at this here, and what I'm going to do is just launch out and move into the Trimble Connect environment, where if my video's not paused, no, it's not paused, it will go. And that'll just show us the visual and the model that has been set up for this particular building. And then we'll be able to take you through and start to demonstrate the link and the integration that's been achieved for this. Now, there's a number of benefits that can be brought forward. First of all, we're populating our asset database from the model, which allows us then to continue to run our existing maintenance processes without having too much of an additional change process put onto the engineers who are going out there and maintaining those assets. As Bill sort of highlighted, a lot of what you need to do in this area can often be engaging with the people to make them accept the new processes. What we're trying to do is embed this within our existing processes, our existing workflows, so that the change and the impact on the people on the ground is minimal. Because going back to what I said earlier, the majority of the buildings that we have will still be there in 2050, so we'll still be running an awful lot of maintenance without models and so on. So if I actually come in, I'm actually moving into one of the rooms that's on this particular building. So it's actually a library. You can imagine that any of the assets within here can be anything. Could be boilers, could be electrics, could be plumbing. It really depends exactly what you've captured. But in this example, we can just show how we can select the individual assets within the model, turning on a couple of the features and facilities within the tool. We're then able to start to select this information and go and find the data within the application on the left. Now you'll notice in there that we've got some core details that come up, so we can very quickly see the serial number, make, model, manufacturer. There's warranty information as well if we want to view that, so I can make sure that I'm always maintaining the assets within the relevant warranty. But I could also go and view the previous work history, everything like that. And I can either do that by looking at that within the Atrium application, or I can pull it up in the properties screen, which is on the right-hand side of the BIM window here. But you just need to sort of set up what data is relevant for you, because as Bill sort of highlighted, it's all about getting the relevant pieces of information out to the individuals who are out on site. Off the back of that, we can look not just at the asset components, the asset details, but we actually want to start to interact with that model in some way. So rather than it just be a case of viewing and accessing the information, or even a seamless way of data exchange into an asset management system, we might want to run some queries against that. So I might want to be saying, I'm turning up on site, I'm an engineer, I want to know what faults do I have in this building, what have I actually been sent here to repair, so I can start to color code the individual assets and the areas that I have issues with, so that I can very quickly highlight not just what the asset is, but also where it is, so then I can find my way through the building, I can get to the problem as quickly as possible, reducing the amount of time I'm spending on that particular job. Similarly, we can run other types of queries like what's the condition. So I'm highlighting all of the assets that have got various condition grades and condition defects and so on. So I know I'm looking at chairs. It's not the best example, but you know, it's an illustration. So I can do that, and I can run even risk ratings. So where are the assets? Where are the components of the building that pose the biggest risk? And risk is something we capture as part of our surveys area, and that could be risk to the fabric of the building, risk to other assets, risk to the user, risk to the environment. Really depends on the type of data that you're wanting to record. So what I'm sort of trying to illustrate here is the flexibility of having having a BIM capability plugged into an existing asset management capability that's evolved over a good number of years, and is used by a lot of clients, is sort of it's adding value to the existing workflows and the existing processes that you're going through, particularly when you're going out there to actually deliver a maintenance. So what we can do here is actually we're starting to utilize the model for collaboration purposes. So we're actually sending out, I'm pretending on the right-hand side that I'm on a help desk perhaps. On the left-hand side, I'm an individual out in the field. And so I'm launching up a secondary model. I'm issuing that out to them, and we connect the two models. So you might have seen it just said successfully connected in the top there. Once I've connected those particular models, the individual who is then out in the field can start to share information between the two people, or vice versa. The person who's on the help desk may be able to send information out. So I can go around. I might have turned up to a job. I've walked into the room. I know I've got a boiler service to do. I've walked into the room. There's 3 boilers. Well, which one am I meant to be doing? I might not have the serial number information, so I could contact the help desk, have them select a particular asset within their view of the model, and it will highlight and flag that model within my own view. So it might take a second to catch up with me. But it's that sort of power that we're trying to bring to the industry, and say it's not just about using BIM for the design and construction process, but we're actually pulling that through into the operational phase. We're not just then using that as a database and drawing on the data, though that's obviously the primary thing that we want to make sure we do from an asset management and maintenance perspective. But then we want to try and use the visuals, not just to make it accessible to the individuals who are on the ground, but also to provide strong visuals up to even board level to say, these are the risks we have, this is the defects that we have, this is why we need to make the investments that we've been telling you about for a while now. So hopefully, as I've been talking through that, you've been able to follow what's going on the video and so on, but I'll sort of stop that piece there. Oh, okay. Just in case it didn't run, I had screenshots. So you've always got to cover yourself with these things. So that's sort of, I think that's an incredibly powerful way of providing BIM and making it accessible in the field, and utilizing a lot of the information that's been captured to improve the ongoing lifecycle management of the building. Once we get out there and we start to make changes, so let's say you go out and you've replaced some pipe work, you've replaced a boiler, you've made some, you might have rewired the building, whatever you've done, or just made some very visual changes, refurbishments, you've knocked down a wall. I sort of have a concern, if you like, that we may go the same route as certainly a lot of the clients that I've worked with have done with their CAD files. So, they go out, they have a new building, or they've had their existing estate completely drawn out in CAD plans, and then Bill goes and knocks down a wall over there, and the CAD technician never updates the model, never updates the plan. So as soon as I go in and say, have you got CAD plans that we can populate the database with? They say, oh yeah, but they're really out of date. So I think that the industry is probably more prepared this time, but certainly is already thinking about it and saying, well, if we've gone out there, we've had the model produced off the back of a construction project, or off the back, like we had there, off the back of a point cloud and so on, how do we make sure that we keep that up to date? We can't necessarily ensure that everybody who's going out there and replacing the boiler is going to be able to update those models. Certainly, if you're looking at tools like Revit and so on, can be very expensive for the licenses, very difficult and tricky to run. Providing tools like Connect can make that model accessible, but won't necessarily give them the ability to go and change the way that the model is set up. So what I sort of try and sort of introduce at that point is you want to just empower those people to capture the information that is changing. Trimble, again, provide a number of different solutions. So this one in the middle, the DPI 8, I think it's called, is a sort of handheld scanner that you can capture the points into. You can feed that into applications that can then provide you the model space, so you could feed that back into the model if you wish to, or you can actually just create the three-dimensional image as a link within the asset register, the asset database, or the model itself to say, this is the information that's changed. These are the piping that we've now installed and so on. So there's tools that are handheld like this, but there's also applications or devices like the TIMS cart, which are for much more wholesale data capture. So you're actually just wheeling it around the room like a shopping trolley, capturing the information that can then be brought into the model. It could be a good way to help model your existing estate for you there over at Princeton. So there's interesting technologies. I'm not going to dwell on a number of these because my colleagues from Trimble and Building Point have got a presentation that goes into quite a lot of depth about this tomorrow at 1:20, which I sort of suggest you go to, or by all means come across by the stand. But I did sort of want to just give you an introduction to, again, just another short video to show you the types of information, the type of data that could be captured by that handheld tool, where we're going out. You can see the scan that we've created. We can select a point on the scan and see where those points link to. So we can start to understand where the piping is run into, and we can then, as I say, drive that into various software tools to build up the model off the back of it as well, which could keep our constructible model up to date, or certainly give us the more accurate information to ensure that the engineers who are going out on site aren't, as was talked about in the previous presentation, sort of mixing good data with bad data. We're able to collect information, make sure it's up to date, and it could be that you only want to do that on certain elements of the estate, some of your more important or more expensive asset types, rather than capturing an entire building, certainly the MEP and so on. So hopefully what I've sort of shown you there is that we have some capability to consume models, build that into an asset management system, and grow the processes that you can then use that data for, whether that's investment planning or whether that's the ongoing maintenance. But yeah, other than that, I sort of really wanted to wrap up. Hope you found that interesting. Do visit us at the stand, or sort of ask me any questions now if you have any. Or have I bowled you all over? You can talk about cricket if you prefer. I'm not a cricket fan at all. That's about my extent on cricket. I don't think we'll win, but no. Is there any questions at all, or is everybody sort of dying for that tea or coffee? Yes, sorry.
Just wait for the mic. Sorry, Dominic.
Very interesting talk, and let's see, that works better. This is Dominic again from AEC Connect. Look, I was quite interested in the RICS example because we have a few cases in Australia where there's clients who are wondering what they can do with their existing built stock. And 3D scanning is obviously coming into the equation, but also what's the percentage of what should we scan and what should we just simply model up because we don't need to scan it. And you very elegantly moved from we did the scan to actually showing us a model which most likely had very little to do with the scan other than using the scan as a backdrop. And I would reckon the time spent on producing a model and entering all the data to the level of detail that would be in the RICS building is probably 1 in 30, 1 in 40, because you can scan these things probably within 2-3 days now, if not quicker. So what is your experience, coming back to my question, and how much should be scanned in these sort of circumstances, and also coming back to some of the more critical voices we heard before, or points we heard before from Bill, what should be scanned and what should we simply model anyway, because the data might be more relevant than having the geometry on it, or we need to simply, the point cloud doesn't help us.
Yeah, I think it's a good question, and the answer is going to be, well, it's going to depend on the asset types that the client has, the industry that client is in. And the reason I say that is With the RICS example, it's been point clouded. Somebody has, it wasn't actually myself, but somebody spent some time going in and registering information into the model that we then pulled into the Atrium database. What we more typically see is that the data for the assets can be much easier captured into, say, Excel. Kobe's an example of one where it's come from a model, but we have a lot of import templates, if you like. We want to see that data in the asset management system to inform the ongoing management. The BIM then becomes a visualization piece unless you get to the point where you're actually using that for data capture. So if you pushed it out and you're actually using the BIM tool to go around, click on the model and enter data into the BIM that then fed in, then you want to have more information available in the model. I think it's going to vary by industry. So, for example, the RICS certainly don't need a lot of information in their model. But if you're someone, say, in the oil and gas industry and you're walking around a complex rig, say, and there's piping everywhere, there's all sorts of complex shapes, and you want to be able to know that you're looking at what you're meant to be working on. You want to click on that information and extract the data right there and then. So I think it's going to vary quite dramatically, client by client, but certainly industry by industry. So, but you're right, there is a time element certainly to making sure that data is input where you've done scanning, as opposed to having it from a constructible model. Does that answer the question? Yeah. Okay. Are there any other questions at all? Doesn't look like it. Thank you very much for listening. Enjoy the rest of the conference.